high school. In fact, I had taught in a school just like that. We had a small junior class and no seniors. All right, but the fact is we could use this, visualize this in a computer where we could therefore access information about the numbers of students in each class. And then if we assumed that 97% of students advanced, we could multiply those numbers by 97 and find out from the number of juniors we have in this one particular high school today, how many juniors we predict, seniors we predict for next year, because the juniors, 97% of them would be expected to be promoted to the 12th grade. So this is an array of numbers that would fit into a matrix. The next visual shows us specifically a matrix. A matrix has these brackets around it. And you'll notice the numbers are those numbers from those three high schools. I've indicated columns, the three columns, column 1, 2, and 3, and the 4 rows. At the very bottom of this visual, it says 4 times 3. That is read 4 by 3. That is called the order of the matrix, O-R-D-E-R, the order of the matrix. The order of a matrix is the number of rows by the number of columns. So this is a 4 by 3 matrix. And what we're going to look at in this lesson is some of the arithmetic of matrices. And then in the next lesson, we're going to use our knowledge of matrices to solve systems of equations. And you'll notice throughout this series, we go back, we cycle back and use or look at previously learned materials. How many times have we used the solution of linear equations or the solution of quadratic equations? Many times. So it's the same thing here. We're going to go back and look at systems of linear equations and see how easy it is to solve them using matrices. Remember those 3 equations, 3 variables? That took some time. With matrices, it will take a lot less time. But first, we've got to learn to operate with them. And the first thing we're going to do is add. Now, adding is the same as counting. When we added whole numbers, we could only add numbers in the same place value. When we added fractions, we could only add fractions with the same denominator. When we added decimals, we lined up the decimal points to ensure that we're adding the same place values. When we added polynomials earlier, very early in this series, we knew that we could only add x's and x's, x squareds and x squareds, x cubed and x cubes. We could only add things that were alike. When we add matrices, we could only add matrices that have the same order. The same number of rows and the same number of columns. And just like when we added numbers in the tens place to other numbers in the tens place and put our answer in the tens place, when we add 2 matrices, we'll add numbers in the same location, let's say first row, first column, and the answer will go in the answer matrix, first row, first column. Let's look at an example of that in our next visual. We have 2 matrices. Notice both of these matrices that are added have 2 rows and 3 columns. They are each 2 by 3 matrices, and we can add them. And our answer has to be a 2 by 3 matrix. And we add them by adding row 1 in first matrix to row 1 in the second matrix. That is 6 plus 4 is 10, 4 plus negative 3 is 1, 2 plus 7 is 9. We add the second row in the first matrix to the second row in the second matrix to get the second row in the answer matrix, which is negative 3, 4, 8. So adding matrices is as simple as adding. But remember, you cannot add matrices if they don't have the same number of rows and columns. Obviously, it would be very difficult to add a matrix that had 3 rows to a matrix that has 2 rows. What would you add the third row to? And you can say you could add it to zeros. No, there are no zeros there because there's no third row in the second matrix. How about subtraction? Well, the rules for subtraction are the same as the rules for addition, so let's look at the next visual, which gives us a subtraction problem. This problem subtracts 2 matrices that have 4 rows and 2 columns. Again, in order to subtract the 2 matrices, we must have the same order. They must have the same number of rows and the same number of columns. And what we do is simply subtract. First row, first column, subtract first row, first column, in this case 2 minus 0, and we put the answer in the first row, first column. Notice that in the first row, first column of the answer matrix, we have a 2. What I would suggest that you do is copy down this problem, that is, copy the subtraction without copying the answer, turn off the tape, subtract, turn the tape back on, and double check that your answer matches the answer in the visual. Okay? Now, what is multiplication? Multiplication is repeated addition. Usually it is. We'll find out with matrices there are two kinds of multiplication. The first kind we look at is repeated addition. Let's look at the next visual. At the top of the visual, it appears to be an addition problem. We have a 2 by 2 matrix added to a 2 by 2 matrix added to a third 2 by 2 matrix. But if you look real carefully, you can see that all three of those matrices are the same. 2, 4, 1, 3. We read across the first row, and then we read the numbers or elements in the second row. So we could also write that as 3 times the matrix 2, 4, 1, 3. This is called scalar, S-C-A-L-A-R, scalar multiplication. It really is a form of addition. We are multiplying the number outside by each and every element, each and every number in the matrix, and the answer you can see, of course, is 6, 12, 3, 9. Now, matrix multiplication is a little more complicated, and some people have a bit of difficulty with it. But what I've tried to do is to show you the first matrix multiplication problem in such a way that it uses colors to sort of identify what we are doing. Okay? So let's look at the next visual. And in the next visual, we have a matrix that's a 3 by 3 matrix. And you'll notice we've colored in circles in the numbers in the first row of that matrix. The next matrix we're multiplying the first matrix by is a 3 by 2 matrix. Notice they are at the same order, but we're multiplying, not adding. And you'll notice in the first column we have similar colors. The way we multiply two matrices is to multiply a row in the first matrix by a column in the second matrix. Add up the terms we've multiplied and put that in a particular location in the answer matrix. So when we multiply the first row, first column, that is the first row of the first matrix, by the first column in the second matrix, the answer goes in the first row, first column of the answer matrix. And then we multiply the first row by the second column. First row in the first matrix by the second column in the second matrix, and that answer goes in the first row, second column. Then we start with the second row, the first matrix, multiplying that by the first row of the second matrix, and that goes in the second row, first column of the answer matrix, and so on and so forth until we're finished. Notice that we've multiplied the first row of the first matrix by the first row of the second matrix, first column. Let me say that again. We multiply the first row of the first matrix by the first column of the second matrix. The number of numbers in the first row of the first matrix has to be the same as the number of numbers in the first column of the second matrix. That is, the number of columns in the first matrix must be the same as the number of rows in the second matrix. Otherwise, we couldn't do this. Well, how do we do this? We multiply the first number in that first row, 3, by the first number in that first column, 4. Notice they're both colored blue. And then we take the second number in the row, 2, and multiply it by the second number in that column, 2. They're both colored green. So we have 3 times 4 plus 2 times 2, and then we take the third number in the row, 1, and multiply it by the third number in the column, -2. They're both colored red. So we multiply the 2 blue numbers, the 2 green numbers, and the 2 red numbers. We get the numbers that are highlighted at the bottom of the visual. 3 times 4 is 12. 2 times 2 is 4. 1 times -2 is -2. And then we add these 3 numbers. 12 plus 4 plus negative 2 equals 14. And that 14 goes in the first row, first column of the answer matrix. Now, since our first matrix has 3 rows and our second matrix has 2 columns, our answer matrix will have 3 rows and 2 columns. What I'd like you to do now is to turn the tape off and finish the rest of this multiplication. That is, multiply the first row of the first matrix by the second column of the first matrix to get the first row, second column, and then multiply the second row using the second row of the first matrix, and eventually using the third row of the first matrix. If you are not sure what to do, rewind the tape back and listen to my explanation again. But try to do this multiplication